Good morning, everyone. Welcome to Fit 5136 Software Engineering again. This is week 5, and today we're going to talk about the software design and modeling. And these are the lecture content that we are going to cover today. Mainly, we will talk about how can we design the software. We will talk about the UML diagrams, which is the visual language that you're gonna use to create the diagrams. And then we will talk about different types of the diagrams, and mainly we will look into use case scenarios, use case diagrams, objects and classes, what is a class diagram and the sequence diagram. All right. And the purpose of this lecture is to help the student to work on the assessment tool. Okay, so for the assessment tool, we will work on the same business client requirement, and then given that requirement, how can we design the software, that kind of thing, okay, using these diagrams. So I hope that all of the students will be able to do that. All right. Yeah, and right now we are still at the early phase of the agile. Okay, so during the requirement, once you get the requirement, you deeply understand, right? The requirement, whether it is the functional, whether it is a non-functional requirement. We talked about that last week. And then now we're gonna design the software, and then you will so that you have like a standard diagrams, and then software developers or software engineers can follow. Okay. And the content of this lecture is based on this book, which is called Systems Analysis and Design in a Changing World. And what I mean is that if you would like to learn more about the lecture content, you just click this link. This book is actually available at the Monash Library as well, so everyone can have access. Okay. Yep. So if you have more, if you like to learn more about the lecture content, then just go to this book. Okay. Then I think before we start the lecture, we need to think about why do we need to design the software, right? And why do we need to model it? Because let's say in real world scenarios, the software is really complex, right? It is really large scale. Think about the Windows XP. Many of you may have used in the past when you were young. It actually has over 40 million lines of code. Okay. Then the key question is that at Microsoft, they don't have software engineers that stay with them for 20 or 30 years. Okay. There's a developer turnover anyway. And then the key question is that, let's say if there is a new software engineer who is joining the company, right, joining Microsoft, then how do they know the architectural design of the whole operating system? So that's why we need to have like a diagram that visualize the high level structure, the high level architecture of the whole software system. How do each of the components interact with each other? That kind of thing. All right. So that's why we need to decide that's why we need to model the software, have a standard diagram, that kind of thing. Okay. And then because requirements are getting larger and complex as well, and there are lots of interconnected modules. Think about the mobile devices that the mobile has to connect to the Wi-Fi module, to the 4G, to the GPS, camera, sound, screen, and everything, right? Actually, like one mobile phone have over 100 modules, and how do they connect that everything together? Because it is so complex, right? If we don't have the diagrams, no one really understand the high level of the software system. How do they connect to each other? And same to the assessment tool, right? Because the client requirement is quite large and complex. If you don't create the diagrams, if you don't create the model, software model, okay, then how each of your team member will have the same understanding, whether like how each of the class, how each of the object will talk or communicate with each other, that kind of thing. That's why we really need the software design and the software model as a standard for the common understanding. Okay. And when we develop the software system, it's not just like one single software engineer, because this is really large scale software project, right? We need to work as a team. That's why we need the software design. And sometimes the code is not really understandable by developers, okay, who did not write it, right? Let's say you write the code, sometimes maybe I don't understand your code as well, because that's why we need to have like a common understanding of the high level structure of the software system, which is software design and the diagrams, this kind of thing. Okay, so that's why in short, in summary here, we really need a simpler representations of the complex software system, and one of them is the software design and the diagram. Okay, so the purpose of the software design, okay, is to specify the structure of how a software system will be written and function, how each of the component interact with each other, okay, without actually writing the complete implementation, right? Okay, because in real world you need to design the software first, how do they connect with each other, and then each of the software engineers have a common understanding. They can develop take the responsibility of each individual component. They don't need to have like one or that kind of thing. Okay, and software design is actually a transition from what the system must do to how the system will do it. Okay, when we elicit the requirement, we understand the functional requirements, what the system must do. It should have the payment gateway system, it should have the customer account management, that kind of thing. But how each of the component will interact with each other, this is the purpose of the software design. So it focuses on how the system will do it, okay, how the system will talk to each other. Okay, and that means within the software design, okay, we will talk about what classes will be implemented to meet the requirement, what is the data that we are going to collect, okay, the class attribute, the data attribute. Are we going to focus, let's say we create the account management system, we will just focus on the first name and the last name. What about the others? What are the data attribute that we are going to collect, you know? And then, yeah, and the most important part is that how each of the classes interact with each other, right? Okay, so to have a standard visual language here, so people call it UML diagrams. Okay, so it stands for Unified Modeling Language, which is a standard language for specifying, visualizing, constructing, and documenting the software system. And it's not just about the software system, but it can be used for the business modeling as well. Think about the business process, you know. Let's say if you go to Kohl's, you want to purchase something, right? Let's say cheese, you know, and then you can create the workflow, the diagram, business modeling, you know. You model the business. First, what the customer need to do, you know, once you have the a standard diagram, then we can implement the software accordingly, okay? So in terms of the diagrams, you know, when you look at the figure on your right hand side here, okay, there are mainly two types, okay, the structural diagrams and the behavioral diagrams. Okay, the UML diagrams, there are two types. Okay, first structural diagrams, second behavioral diagrams. For the structural diagrams, basically we want to display the organizations of the system, what are the components there, okay? What are the components in the software, in the diagrams, that kind of thing, okay? So it's quite static, right? But when we talk about the behavioral diagrams, we talk about the dynamic behavior of the object, what the object will do, that kind of thing, how each of the objects communicate with each other, okay? So behavioral diagrams is like behavior. We talk about the activity, okay? It's quite dynamic. But when we talk about the structural diagrams, we just talk about, well, yeah, what are the things in there, okay? Think about, you know, let's say we buy a fruit box or no, what is a good example here? Anyway, okay, structural diagram, just like static, okay? There's no activity there. We just talk about what is in there, okay? But the behavioral diagrams, we talk about how each of the objects communicate to each other. That's a behavior, okay? And because there are so many diagrams, okay, in real world scenarios, we cannot cover everything. To make sure that everything is quite manageable within the unit, within the assessment workload as well. So we will focus on the three things, okay? Use case diagram, class diagrams, and the sequence diagram. This is the three key diagrams that we are going to focus within this unit, all right? And then I'm gonna walk you through one by one, okay? This is an example, okay? Use case diagram, very basic, very common. Basically, you just define the boundary of the software system, who will interact with what, Okay, that means okay, based on the definitions here, okay, use case diagram summarize the details of the system of your system users, also known as actor, and their interactions with the system. Basically, it describes how the users interact with the system. Okay, like in this example, okay, the figure on the right hand side here, you have the boundary, okay, which is the and we call online shopping system. Okay, this is the boundary. You have an actor, which is the customer here, okay, on the left hand side, okay, and then you have the circle that actually describe the use case. The customer can view the items, customer can make the purchase, okay, customer can do the login, and then whatever exists on the right hand side, the live mode, the right mode, okay, it will be the third party actors, okay, external actors. We will talk about that later, okay. Yep, that's a use case diagram. The second one here is the class diagram. Basically, it visualizes how the object classes in the system and their association between each other. Okay, think about you go to the concert. You need to access to the ticket management system. You know, and when you book a ticket, right? You have lots of concert band. Okay, and like in this one, it show there's a band member. So first we have like how many bands. Okay, and bands are associated with the concert as well. How many concerts are there? Okay, and we have for each of the band also have lots of band member, right? So that's why in this diagram we talk about how the band member, the band, and the concert are associated with each other. Okay, we'll talk about the details later. All right. Next one is the is called sequence diagram. It create or describe the flow, okay, of the objects within the system. How each of the object will interact with each other. Okay. First step in a more sequential way. Okay. Sequence. Okay. Sequence diagram. First, we have an object here, interact with that, that kind of thing. Okay. In a more time sequence. So the first two diagrams, okay, there's no time sequence at all, okay. This one is quite static. We have an actor, the user. How does it interact with the system? Okay, we have the boundary. This is a class diagram. Within the system, we have lots of objects, how each of the objects interact with each other. And then, given one use case scenario, how the actor or each of the object will interact with each other in a time sequence, okay? Simple like that. This is the last one. Probably. No, more types of the behavioral diagram. Okay, this is called activity diagram. Basically, it describes the flow of one activity to the other, not the class. Okay, this is the activity. Let's say we want to purchase something, right? Okay, first we receive an order, we fill an order, arrange the delivery, that kind of thing, and then once everything is finished, then we can send an invoice, receive the payment, that kind of thing. All right, so this is more like the flow of the activity, not the classes, not the objects at all. All right, state machine. Okay, we just describe the process of something in a more state, okay, using the state diagram. Okay, this one is an example of the washing machine. Okay, first, we have the running cycle, that kind of thing, you know, but the most important part, we need to have the power on, power off, you know. So at the beginning, we have three states, right? Washing machine. First, we do the washing. Once it is washed, your clothes, then we start rinsing, spinning, that kind of thing. But let's say if there is a power cut, it will do some power off, and we can restore the power, that kind of thing. So it's more like the state of the process, okay, not about the class, not about the objects and everything. Again, this the state diagram, okay, is part of the behavioral diagrams. Okay, on the left hand side, structural diagrams. Within the this unit, we only focus on the class diagram only. For the behavioral diagrams, we focus on the use case diagrams and the sequence diagram. Okay, very good. Okay, and then why do we need to use the UML diagrams, right? Because we have to use it as a sketch. At the beginning, you know, when we have like a bunch of the requirements here, okay, and then it is so difficult to start implement or have a high level understanding of the software system, right? Because otherwise it costs a lot of time to modify and change. So once we have all of the requirement, it is a good practice to sketch how the system will look like, okay, how are we going to implement it at the beginning, right? And that's why we call forward design. We do the UML, okay, design the UML diagrams before the coding, right? And then normally everyone in the team should brainstorm and discuss with each other, because this is the given requirement, this is what we are going to implement, these are the requirements. What are the objects in the system? We need to analyze the requirement, identify the objects, identify the activity, and then we can draw the diagram. And then we can design the software accordingly, okay? So the purpose of using the UML is to use as a sketch. We can use as a blueprint as well. This is the final tentative complete design to be implemented, right? And we can use as a programming language as well, okay? All right, so use case diagram, what is that? All right, we're gonna go through that. 1 second. Okay, use case diagram, basically it is a set of the use cases, okay? A use case is a model of the interaction between the actors, the external users, and the software product itself, okay? And more precisely, an actor is also a user playing a specific role, describing a set of the user scenarios, capturing the user requirement, and as a contract between the user and the software developers as well. I'm gonna show you what is that, okay? Now, before we draw the use case diagrams, we need to know the notation, okay? The notation. And these are the key notations of the use case diagram. I'm gonna walk you through one by one. Let me get a pen, all right? The most important thing, okay, when you draw the use case diagram, you need to define the boundary, all right? You define the boundary, and then you describe what is this system, okay? So the system boundary is the rectangle diagram representing the boundary between the actors and the system. This is a boundary. Our online shopping system whatsoever, all right? And then who is the actor? Actor is the role of that a user plays with the system, that kind of thing, okay? So we draw, this is an actor, okay? We have the boundary, we have an actor. And then we're gonna create the use case, okay, which is a set of the scenarios that describing the interaction between a user and the system, okay? So like in this case, when we create the library system, what is the purpose of the library, okay, is that the student, okay, can borrow a book, okay, and once they borrow a book, we have an employee here, we have a library supervisor here, which they can borrow a book as well. They can order title, they can submit like a ticket to charge you like fine, let's say if you return the book late, that kind of thing, okay? So this is the diagrams that actually visualize, okay? The line will indicate or describe who will interact with which use case, okay? For example, like this one, client can borrow the book, client can get the file remittance, but the client cannot order the book title, that kind of thing. Only the employee and the library supervisor can order the title, okay, the book title, this is an example. All right. Okay, next we need to learn about the include and the extend notation as well, okay? So include, it is represent as a dot line, all right? Dot line, actually I should say dash line, label with the include, beginning at the base use case and ending with an arrows pointing to the include use case here, okay? We use include to describe the mandatory activities, okay? Mandatory mandatory use case, okay? I'm gonna show you later, okay? So but in here what do we need to know is that we have two more notations, okay? Include and exclude, all right? Okay, include here relationship represents the behavior that is factored out of the use case, okay? And include is also, how can I say? I think I should have the a better definition or not. Let me see. Let me see. Let me try to explain this one. Probably if I explain the figure, it will be much easier. So let's say this one, right? You have a passenger, okay? Passenger, you want, and let's say ideally you should have a battery, okay? You should have the battery, but this one doesn't, okay? But anyway, but the key point here is that we use the include as a mandatory use case, like a follow-up use case, you know, but when we will use extend as an optional, okay? This is the key difference, okay? For example here, all right, passenger first, they need to purchase the multiple ticket or the single ticket here, okay? Once they go to the purchase a single or multiple ticket here, what do they need to do is the next step is to collect the money, okay? This is like a follow-up, the next step use case after the base use case here, okay? Once they collect the money, and now we use the extend as an optional use case, because when they collect the money, if we provide the money enough, then there's no exchange, okay? Otherwise, the passenger can also cancel the transaction as well, you know? So this is like the key difference between the include and the exclude, okay? No, not include and exclude. Include and extend, okay? Yep, and this is the include. Extend, basically we use the extend to represent exceptional or like optional use cases, okay? For example, all right, this one we have the passenger again, okay? We're gonna develop the train ticket management system, okay, where passenger can purchase the ticket, right? But this is the optional scenarios, optional use cases that passenger can access, okay? For example, the machine can be out of order, what it will do, okay? They can cancel the purchase the ticket, that kind of thing. This is like a no change, no money exchange, okay? Once they do the payment, or the operation timeout as well, okay? So this is the extent. It is not mandatory, okay? Whenever it is mandatory, you have to use include. If it is optional, you use the extend. That's the key difference. All right. Okay, so to define the use case diagram, to draw the use case, what do you need to do is to first identify the actors, okay? Once you analyze the requirement, you should understand who are the actors that will interact with the system, okay? The key question that you should answer here is that who use the system, who install the system, who start the system, who maintain the system, who shut down the system, that kind of thing, okay? Once you know the actors, then you identify the use case or the activities, okay? That means what are the activities or the functions that the actor will do with the system, okay? That's the key point. You identify the actors, you identify the use cases, and then you identify the boundary. Draw the boundary, draw the use case diagram after that. These are the three key steps to draw the use case diagram, okay? Let me give a better example here, okay? Train ticket system. This is the requirement. This is an example. Requirement. First, a customer can purchase a train ticket, okay? The payment can be made only via EPOS, which will be authorized by the EPOS system. Once the ticket is purchased, the customer can print the ticket details, okay? The second requirement here, a customer can modify the date and time of the purchased ticket or cancel the train ticket. However, the cancellation request must be approved by the staff. The EPOS will make a refund to the original payment method for the canceled ticket, okay? First, what do we need to do is to identify the actors, okay? Who are the actors here? Okay, normally we look for the now, okay? First, we have the customer as an actor. We have the The payment can be made only via the EPOS. Okay, this is the third party actor which will be authorized by the EPOS system. Once the ticket is purchased, the customer, okay, again the same actor can print the ticket details. A customer can modify the date and time of the purchase ticket, blah blah blah, however, blah 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 blah, by the staff. Okay, this is another actor. Okay, the post will make a refund to the original. Okay, blah blah blah. All right. So now we get the actors, right? 1 second. Next, we identify the use case, the activity, how the actors interact with the system. Okay, so a customer can purchase. Okay, this is the use case number 1. Purchase a train ticket. The payment can be made only, okay, via EPOS. Probably they need to make a payment as well. Okay, but probably it is part of the purchase. Okay, which will be authorized by the EPOS. Yes, once the ticket is purchased, all right. So purchase, that's the same use case. The customer can print. Okay, this is the second use case. Okay, a customer can also modify as well. Okay, the verb, another verb, the date and time, all right, of the purchase ticket, or cancel. Okay, this is another use case. Yep, that's right. Purchase, print, modify, cancel. However, the cancellation request must be approved by the staff, blah, blah, blah. Make a refund. EPOS will make a refund, okay? A refund, yeah. Yep, to the original payment method for the cancel ticket, okay? Yeah, so refund is part of the cancel, so that's why I will not create a new one, all right? Now we have the actors here, we have the customer, we have the staff, so we distinguish as two types of the actors. Okay, we have a passenger, we have the staff. The first use case here is the purchase. I'll say, okay, so we draw here, purchase the train ticket. The second one, they can print. Okay, print. Is it mandatory or not? This is something we need to think about. They can print, okay, but they don't need to print. They cannot print as well, but they can. Okay, it doesn't mean that the customer must print the ticket. All right, it's not. They can print, so it is optional. That's why we use the extend to describe the relationship here. So this one is the extension of the base use case. Okay, purchase train ticket. All right, makes sense to everyone. Then the customer can modify the date and time. Okay, this is another use case. Okay, of the purchase, or cancel, okay, the train ticket. That's another use case as well. Okay, so when they modify date and time, modify the train ticket, they can cancel the train ticket. Okay, however, the cancellation request must be approved by the staff. Okay, so that's why the cancellation request must be approved by the staff. The staff have to approve the ticket cancellation. All right, the EPOS will make a refund to the original payment method for the cancel ticket. So that's why the cancel here. Okay, we interact with the EPOS. Okay, and the EPOS have to actually I forget one more thing. The payment here, after they purchase, they need to do the payment. That's why we have this line here. All right, then the next question is that why do we have include here, right? So when they modify date and time, okay, purchase of the purchase ticket, they can also cancel as well. So during the modification, they can also cancel. That's why they can either go to the modification page, okay, modify, and then they can cancel, or they can cancel directly. Okay, that's why we have the include relationship here. Okay, does it make sense? It cannot be extend. This is not optional, that kind of thing, but it's more like the next step. Okay, after the modification, the modify page, right, and then they can cancel the ticket as well. Okay, any questions with this example? Okay, no question, and then maybe I will move to the next example. All right, which is a more difficult one. Okay. Some questions in the Q&A. Does extend have to do anything? Have to have anything to do with the order in which events occur? Like once the ticket is purchased, the customer can. Uh, I would say kind of, okay, because when we say extend, it is the next use case. What I mean is that passenger have to purchase the train ticket, and they have an option whether they want to print the ticket or not print it. But the next question is that can the passenger print the ticket by itself? No. Okay, so what they need to do, they need to purchase the train ticket first, and then they have an option to choose whether they want to print the ticket or not print the ticket. So that's why we use the extend relationship here. Thank you for your question. All right, so I'm gonna move to the next one. Okay, example 2, online clothing website. Okay, so let's analyze the requirement together. Read. We will go through one by one. Okay, a customer. Okay, the first actor can search. Okay, for clothing products. That's the data attribute from an inventory management system. Probably could be another actor as well, but the external actor. A customer, okay, the same one, can view. Okay, can view. They can search, they can view individual products that are available in the inventory management system. Okay, so that's the external actor. A customer again can manage a cart as part of their shopping experience. Okay, a customer can check out the items in their cart. Okay, during the checkout now, okay, looks like we have something. Okay, during the checkout, when a user has confirmed their order, okay, during the checkout confirm their order, looks like this is something, the next step after the checkout. Okay, when a user has confirmed their order, they will be able to submit shipping and payment detail. Okay, submit shipping payment details. Okay, which connected to an external payment service. Okay, looks like this is another external actor. Okay, a customer can buy, okay, a product directly without a card. Okay, all right, they can buy. They don't need to have the shopping cart. Okay, so looks like a buy now. Okay, when viewing, so this is another use case as well. I will call it buy now. Okay, maybe just only one. Yep, buy now. When viewing an individual product, a customer can select buy now to proceed to confirming their order of the detail. Oh, looks like eBay. Okay, like Amazon as well. To proceed to the confirming their order of the detail. So buy now and then go to the order of the item. After confirmation, okay, so confirmation, they will be required to submit shipping and the payment details. Okay, the same one. All right, a customer can submit shipping details. Okay, to complete an order, a customer is required to enter shipping details and payment details that are verified by the third party payment system. Okay, so it has to be connect to the third party here, and this is the extension. Okay, a new advanced search feature will be added to the website in the future. The feature will allow customer to include additional parameters when searching for product. Okay, search. The search feature will be implemented, okay, in the future. All right, let's draw the diagram together. I'm gonna move my face a little bit, okay, maybe here. All right. Okay, definitely the first thing we need to do is to draw the boundary. All right, draw the boundary. We write the system name, which is called online clothing website, and then draw the primary actor here. Okay, customer, which is called customer, and then actually I should not call external actor, I should call supporting actor. Okay, maybe to be consistent. Yep. So supporting actor. Okay. Yep. All right. SA. First thing first, customer, what do they need to do? Okay, search the product, right? This is the first use case. They can view the product as well. All right, they can manage the cart. Okay, they can check out. Okay, check out. All right, one by one. Okay, this one go. They can buy now. They can do buy now. Okay, buy now. All right, once they have the buy now, they need to submit the shipping payment detail. Okay, these two. So that's why we draw this. Okay, and this, right? And it is include because they what is that, confirm the order. So that's after the checkout. Okay, then they can do the submit shipping. Okay, after buy now, they have to do the submit shipping. So it's like the next step, it's not the first thing. No one submit the shipping and the payment details at the beginning, right? Okay, so that's why we use the include relationship here. And then a customer blah 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 to complete order, a customer require enter shipping details verified by the third party payment system. Okay, third party, that's why we connect to here. This is the supporting actor, and at the beginning, during the search, the view, and the search connect to the inventory, the view. Okay, check out card, do they say anything? I think during the checkout, yep. Checkout, I think, no. Checkout, I don't know. During the checkout, a user has confirmed their orders. They will be able to submit the details, which connected to an external payment service. I would say that checkout, it has to be this line, okay? Rather than that line. Nope. That's not right, okay? Checkout connect to the external payment service. And same to this one. To complete, customer is required shipping detail, payment details are verified. Yeah, that's why we have this line. All right. Okay. And this one, the search feature, is an extension, right? Yep. This is the advanced search. Okay. So it's not this line, because this is the advanced. It is the extension of the existing search product. So that's why we use the extend relationship to describe the advanced search here. All right. This feature will allow customer to include additional parameters when searching for products. So yeah, during the search product, we can have advanced search feature. Okay. All right. Beautiful. Any questions with this example? Is it crystal clear to everyone? I also want to mention this one as well. By convention, okay, primary actors appear on the left, okay, and the supporting actors appear on the right side, okay. So we know that the inventory management system, just like some other system which can be connected via the API, just a supporting actor, but not the main actor of the online clothing website, okay. Same to the external payment service as well. All right. Okay, next. All right. Apologies, I was sneeze, okay. I mute on Zoom, but I just realized that I use another app to record the video, so you may not hear my sneeze sound, but if you watch the record on YouTube, you may hear. That's a funny thing. Okay. Yes, you have a question. Yeah. So we got a question, okay? Why buy now is not after the view product? Because it says here that as a customer can buy a product directly without a cart, right? So basically they have an option to create a shopping cart, okay? Manage the shopping cart, or they can do the buy now, okay? Just buy immediately without the shopping cart, okay? Yep. But your question is that when viewing an individual product, right? Okay. Good point. Good point. Good point. I would say like this, okay? This is the use case, but it's not the sequence diagram, okay? So it doesn't mean that they have to. If we draw the sequence diagram, we may say that yes, they need to view the products and then they can do either manage cart or buy now. Otherwise, if we follow that kind of thing, the use case will be extremely complex because it will have lots of dependency. What do I mean is that it should not be like a diagram or workflow, that kind of thing, okay? This is the use case, what the customer can do, okay? Rather than the flow of the system. You know what I mean? We need to be a little bit, how can I say? Yeah, so in short, what I mean is that this is the structural diagram, not the behavioral diagrams. We just describe what the user can do with the system rather than the workflow of the system, what the user need to do something and then they can do something. Not like that. Yeah. Okay. Thank you for the question. All right. Okay, so maybe I will explain about the extend and the include relationship again. Yes, one question in the Zoom chat, you mentioned that include is a compulsory action. Yes, that's correct. Okay, that the user has to go to. But for the extend is optional. That's correct. That's right. Yep. Extend is optional. Include is the mandatory. Yep. It is compulsory. Yep. Because when you do the checkout, you can do the buy now. What you need to do next is that you need to submit the shipping detail. Yeah. Otherwise, we won't get money. Okay. All right. Well done. Next. Okay, next. What is a use case scenario? Now we just talk about the use case diagram, okay? And now this is the use case scenario, okay? Normally, we start from the requirement and then we draw the use case diagram for each of the use case. In the use case diagram, we will need to explain or talk about the use case scenarios, okay? So a scenario is a sequence of actions that illustrate the behavior, and a scenario may be used to illustrate an interaction or the execution of a use case instance, okay? Scenarios are used as in a scenario-based requirement elicitation, which is a technique of asking questions related to a descriptive story in order to ascertain the desired requirement. All right. In short, okay, what I want to say here is that previously, if we go back to the first slide, all right, a use case diagram is a set of use case, okay? Because in one diagram here, we have multiple use cases like print the ticket, purchase the ticket, modify the ticket, and cancel the ticket, okay? For each of the use case here, we will talk about what are the scenarios, how the customer will interact with the system for each of the use case in detail. That's why we call it use case scenario, all right? So that's why, let's say this is an example, right? This is a requirement, okay? A customer can purchase a train ticket. The payment can be made only via a post, blah, blah, blah. Once the ticket is purchased, blah, 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 which is the same as this one. No, this one, train ticket. This is the same one, all right? But with this figure, okay, this diagram, there are so many use cases. Next, we're gonna talk about how the passenger can purchase the train ticket in details. We're gonna create the scenarios. Okay, so this one is called use case scenario. And a use case scenario is the sequence of the actions. Okay, now it's more like the behavioral something now, okay? And then the scenarios are a set of scenarios tied together by a common user goal. Okay, so the user goal here could be, let's say, to purchase a train ticket. How the end user or the actor will perform or act with the system. Okay, interact with the system. When we create the use case scenarios, there are two types of the scenarios. Okay, the main scenarios and the alternative or exception. Okay, a main scenario is a set of interactions between the user and the system. Okay, that correspond to the way we understand how the system should be used towards a goal. Okay, and the alternative scenarios is like a which is the result of the exception condition that interferes with a normal scenarios. Let's say I'm gonna give you an example. Okay, back to the train ticket system. Okay, purchase the train ticket could be the main scenarios. Okay, modify the train ticket could be the main scenarios. Cancel the train ticket could be the main scenarios. Exception or the alternative scenarios could be, oh, we run out of the train ticket. Okay, I am going to purchase something, but it is sold out. When it is sold out, that's the alternative or the exception, right? This is the same thing when you implement like a exception handling in Java. When you want to purchase something, okay, but then the ticket is not available anymore, that becomes the exception handling, right? Okay, does it make sense? Anything that is like an alternative, that anything that is like an exception or they are interfere, is like not like usual, then we call it alternative scenarios. Okay, let's try to work on this one together. Okay, this is a template. Okay, in general, you need to write what is the use case name, the name. Okay, what is the scenario, how does it trigger. Okay, the brief description, how the actors involved. Are there any related use case? Are there any preconditions, post condition, and then what is the flow of the event? We need to write the steps, okay, in the use case. This is an example. Now, we have purchase, modify, cancel, train. Okay, so many things. We're gonna write only one. Okay, let's say we're gonna write about the purchase, modify, and cancel train ticket all together. And this scenario is called a customer wants to purchase train ticket, modify the date and time, and cancel the ticket if necessary. Okay? The customer access this scenario will be triggered when the customer access the train ticket booking system. Okay, this is how it is triggered. Just a brief description. Okay, this use case describes the process of a customer purchasing a train ticket. Blah, 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 blah. And then the actors will talk about who are the actors that are interacted with this use case. Okay, first, definitely the customer, which is the person who wants to purchase, modify, and cancel the train ticket. We need to have the train ticket booking system. We need the airport system, okay, to verify the payment. All right, okay. So what do we have here? We have use case, scenario, trigger, brief description, actors, and then we're gonna talk about the rest of them. Okay, this is the flow of the event. Okay, the flow of the event here. Basically, we just write or explain the scenarios. First, the customer have to select a train, date, and time for the journey. The system will calculate blah blah blah. The customer select the payment method. The system will redirect blah 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 blah, and then the customer can print the ticket, that kind of thing. So this is the flow of the event, which is a more detailed description for each of the use case that we draw in the use case diagram. Okay, does it make sense, everyone? Use case diagram is a set of the use cases. For each of the use case, we should write or describe the use case scenarios, which explain the flow of the event. Make sense? Okay, and then the exception condition here should be, for example, okay, payment authorization failure, the ticket is sold out, the machine is out of order, how the system will interact with the user, that kind of thing. That's the exception condition. Okay, all right, yep, that's all for the train ticket system. That's all for the use case scenario. Any other question? If not, I am going to move on to the class diagram. Okay. Class diagram basically represent the whole structure of the system. Okay. We used to we normally use the class diagram, especially when we use the object oriented programming language like Java, Python. When we want to implement anything in OOP style, then we need to have the class diagram, so we know what are the classes, how do they interact with each other, what are the association between the classes, that kind of thing. Okay. And normally when you create the class or the object, you just identify by the nouns. Okay. These are the nouns. I mean, normally the nouns will be represent as an object, that kind of thing. Okay. All right. But the next and how do we decide the classes? Okay, this is the notation. First, we need to identify the objects from the requirement. Okay, when you read the requirement specification, identify what are the nouns, which could potentially be the classes, objects, or fields. What are the verbs? Okay, and these kind of verbs could potentially be the methods or the function or the operations or the responsibility of each class. Okay. And class is actually just a concept, right? It's not the real thing. Class is a just conceptual object. Okay. And basically a class, okay, encapsulate the attribute, the data attribute, and the operation. What are the behavior? What are the data attribute of each classes? And then each attribute also has a type as well. For example, could be the string, could be integer, could be the number, that kind of thing, right? Okay. And each of the operation also has a signature. For example, like this one, price, it can be like anything. The class name is the only mandatory information. When you draw the class diagram, the only thing that is mandatory is the class name. The rest is optional. You can, but what I mean is that it will be a blank class, which is a class that has no attribute and the operation at all, which is weird. But anyway, in terms of the notation here, okay, the class name is the only thing that is mandatory, because otherwise we cannot call it what is that class. Okay, what is the difference between class and objects? Okay. Objects are often derived from one of the following sources. It is something that is tangible, real world things, roles, event, that kind of thing, right? Object in real life, how can I summarize here? I try to summarize and make it simple, okay? What I mean is that, okay, objects are the real thing. Class are the concept, okay? That means normally when we create the class diagram, this is a conceptual class diagram. Once we have the class, then we can create the object, all right? And whatever the object have the property values or the method, it will be the same as a class, okay? This is an example. A class basically describes a group of an object. As I said, okay, a class is the concept. We have a concept of the dog, right? Okay, but in real world scenarios, we have too many dogs, which the name can be Rain, Ryan, whatsoever. Okay, I will not mention the name, okay, the dog name. But what I mean is that in real world, okay, we have like millions of dogs which have some common properties and the method. Okay, the common properties here could be the color. Okay, they have the eye color, they have the height, the length, the weight. They can do sit down, they can lay down, they can shake, they can come, that kind of thing. This is the common method, common operation. But each of the dog may perform differently. But there are some common properties, common method, okay? And the concept of the dog here is called class, all right? Does it make sense? The concept of the object is called class, but when we have the class, create the class, it becomes an object, okay? Does it make sense, everyone? That's the OOP, okay? Yep, as I already mentioned, a class can have data, attribute can have operation, blah, 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 An object is one individual with different values. So we have the dog, just a concept, but we can create multiple objects, okay? Multiple dog objects here. Yep. One can be gray color, another one can be white, another one can be black, another one can be brown color. That's the object, okay? All right, so Class diagram, it is actually one of the most useful types of the diagrams in UML because we use to describe the classes, what are the data attributes, and how do they interact with each other. In real world, we really need it, okay? And in terms of the notation, what do you need to do is that to draw the class diagram, okay? One class is just a table like this, okay, with 3 compartments. The first one is the class name, where are we? This should be the class name, okay? The second one describe about the data attribute or the properties, and the last one we describe the operations and the method. All right, only 3, simple like that. Okay, this is an example. Okay, when we draw the class diagram, as I mentioned to you before, the only thing that is mandatory is the class name. Okay, so we create the person like this. Okay, totally fine. We create the person with the data attribute name, address, birth date without the operation, which is also fine. Okay, person, this is fine. This one missing, no, we don't know what is that class. Okay, we have the person, no data attribute, but there's an operation, which is totally fine. But this is the complete version. Okay, this is the complete version. This is what it should be in the assessment. If you draw something like incomplete like this, there's a higher chance that you will not get the full mark. Okay. Okay, next. Yep, I already talked about the elements of the class diagram, right? We have class, attribute, operation, but there are a few more things that we need to know, which is the relationship. Okay, relationship and the association. There are different types of the relationship. I will talk about that. Okay. This is what I mentioned to you before: upper section, middle section, bottom section. Class name, data attribute, and the operation. Yep. When one more thing. Okay. Inside here, inside here, inside the class diagram. Okay. This one is the data attribute. Okay, we collect the name, the ID, the age, and then the bottom section we talk about the what is that, the operation. Okay, but we also need to understand the notation here as well, which is called what? Publicity. Yep. Access. What is that? The scope. Okay. Visibility, access modifier. Yep, access modifier. Okay, there are different types of the access modifier. For example, public denote, we use the plus, okay, as a symbol. Okay, private minus, protected chart, package, this kind of symbol. Okay, like in this one, we use minus as to describe that name, ID, and age, they are the private. Okay. So probably if you learn Java, you may know this kind of thing already, that public, it means that this kind of data or attribute or operation can be accessed by any class. Private, it cannot be accessed by any other classes at all. Protected can only be accessed by the same class. Okay. Package can be used by any other class as long as it is in the same package. So it depends on the scope of the modifier that you really want to describe. Okay. That's the notation. All right. So what you have to know is that you learn about the class, attribute, the class, data attribute, the operation, the access modifiers. Okay, there are different levels. The next one is the association and the relationship here. Okay. Now, so association, right? So basically we use to describe the relationship and the composition. Sometimes the class belong to something. Sometimes the class is associated with something. Okay, so it really depends how are we going to describe the relationship. Okay, look at this figure here. Okay, we have 2 things. We have the owner, we have the pet. Look at the description, right? Normally, typically, owners feed the pets, and the pets can please the owners. Oh, thank you, that kind of thing. This is the association, because owner can have multiple pets, that kind of thing. and pet can be belonged by one or more owner whatsoever. This is more like association, the relationship. But when we talk about the components inside the dog here, right? A tail is part of the dogs and the cat, okay? This is the aggregation and the composition relationship, okay? A cat is a kind of the pet, okay? So this is more like inheritance and the generalization. What I mean, okay? What I'm going to say is that owners and the pets here, okay, they have relationship. One owner can have multiple pets, that kind of thing. But the pet itself, which is an animal, right? They have eyes, okay? They have arms, they have legs. Oh, no, they don't have arms, sorry. The dogs have 4 legs and the tail. So this kind of thing belong, okay? It's about belonging. Belongs to the dog. So we're gonna use the aggregation and the composition, okay, to describe the relationship, all right? Okay. So in short, okay, class diagram, there are 3 types of the relationship, okay? Association, aggregation, and the composition, okay? Association is about, I will talk about that, multiplicity, that kind of thing. What should I do? Maybe go through one by one, start from the association, okay? Association, there are 2 types of the association, okay? Bidirectional, okay? Or unidirectional. Unidirectional here, okay? I will start with the bidirectional, okay? So bidirectional association we use to describe the relationship between the 2 classes. So both classes are aware of each other and their relationship with each other, all right? And this association is represented by a straight line between the 2 classes. Straight line with the 2 classes. And there are different, okay, multiplicity here. For example, one has one has many, many has one, many has many, okay? Like this one. See, okay. Maybe I will explain this one, okay? This is an example of the multiplicity of the class diagram, all right? So, first thing first, okay? We normally we draw like this, okay, between the 2 classes. But here we just want to describe what does this mean, okay? 0.1, it means that 0 or 1, okay? If I say 1, it means 1 and only 1. This is mandatory, okay? 1 and only 1 alternate, mandatory. This is 1 and only 1 alternate. So either what is the difference here? 1 and only 1. I think this is the same, okay? This is the same. 1 and only 1. This is the same. All right. So what do we have here? 0 or 1, 1 and only 1, 0 or more. So we use 0 ... and then star, okay? 0 or more. 0 or more alternate as well. This is optional. 1 ... star, so 1 or more, that kind of thing. All right, okay? So this is the multiplicity. I'm gonna go back. So we have different types of the multiplicity, and this is an example, all right? So we have the car and the road trip here, okay? We have 2 classes. The first one is the car, another one is the road trip, okay? The car has 3 data attribute, okay? With the publicity modifier, not the publicity, with the public modifier, okay? And with the data type string, integer, and the string here. This one is private. These 2 are public, okay? All right, for the road trip, okay? Each of the road trip, we can have snack, we have the fuel level, we can have the radio station, which route, okay, start to the end, do we need to detour or not, and the potty break, that kind of thing, okay? And then what you need to explain more is, so the car and the road trip has bidirectional, okay, association. And we use 0.1 to describe that each of the road trip, okay, must have 0 or 1 car, okay? okay, make sense. But the car, okay, can have multiple road trips here, okay, zero or many, okay. Sometimes the car never have a road trip as well, so that's why it can be zero, okay. Yeah, since one car inside could have multiple road trip as well, in other words, one car could go on multiple road trip, that's why the multiplicity value is set to 0 to 1, okay. So some car doesn't have road trip at all, some cars can have multiple road trips, that's why we use 0 or more to describe the multiplicity. For each of the road trip here, okay, so sometimes there is no car associated with it, right? So that's why we use a 0 dot dot 1, okay? Make sense? Yep. So this is the association based on this description. All right. Next. So we talk about the multiplicity, okay? This is another example, all right? We have a concert band class diagram here. So we have 3 classes. I will start with the band, okay? The band, these are the data attribute whatsoever, okay? And then, if we take a look of the relationship between the band and the concert, right? What I mean is that the band, some band never have a concert, okay? Oh, I'm so sorry. Some band never have a concert, but some bands can have multiple concerts as well. So that's why we use the 0 or more to describe the relationship here, okay? But for each of the concert, okay, we cannot have a concert without a band. So that's why each of the concert must have one or multiple bands, okay? Let's say this is a very big concert. We have multiple bands, that kind of thing. But we cannot have a concert without a band. Does it make sense? Okay? That's why we use 1 dot dot star here. Now we're gonna look at the band member and the band, okay? So band member, one band can have one or more member, okay? The band cannot exist without a band member, okay? So they need one or more. But at least one band member can have a band already. So that's why one and only one can have a band, okay? You never see like one band member appears to many bands. Does it make sense? It belongs to like one, okay? One band member just belong to one band, okay? So that's why we use 1 to describe the relationship here. One band member, okay, has only one band. Make sense, everyone? All right, next. Yep. Next is the unique directional association. Okay, so we often use this one to describe the what is that? Wait. Sorry. Unique directional association. So it is less common. One class is aware of the other and interacts with it. It doesn't describe the multiplicity. Okay. This is the unique direction. Okay. So unique directional, it means that it has only one direction. Okay. It doesn't have two. All right. Only one direction. So we use the arrow like this. That means each of the car may get the speed enforcer. Okay. So it is like only one direction. Okay. As an example, on your road trip through Arizona, you might run across a speed tab where a speed cam records your driving activity, but you won't know about it until you get a notification in the mail. It is drawn in the image, but in this case, the multiplicity value would be 0 depending on how many times you drive by the speed cam. Okay. Yep. So the car can have 0 or more speed cam enforcer, right? Got detected by the speed cam record, but it may not at all. So this is like one direction. Okay. Yep. Next one is the aggregation or someone called has a relationship. Has a mean belongs, okay? Belongs. So that means there are two types of the has a relationship here. The first one is called aggregation. The second one is called composition. All right. Aggregation describes the relationship where the child class can exist independently. Okay. But the composition describes the relationship where the child classes cannot exist independently. Okay. No, sorry. The composition describe the relationship where the child cannot exist independently. Yeah, that's right. I'm confused. Okay, let me give you an example. What does it mean? Exist independently or cannot exist independently. Okay. Okay. Now, let's take a look at the aggregation. The teacher and the student, right? When we create a classroom, we have teacher as a parent class, we have the student as a child class. Can teacher and the student exist on its own? Yes, right? Because sometimes there's a room with a full room of the student, but no teacher at all. But sometimes we have teacher but no student at all as well. So it doesn't belong to each other. So they can exist on its own. Okay. So teacher, for in this case, we use the aggregation to describe the relationship. But for the house and the room here, okay, the room don't exist separate from a house, right? Because the room has to be inside the house or the building, that kind of thing. So here, the child class cannot exist independently of the parent. That's why we use the composition relationship. Okay, I'm gonna give you a more example in the next slide as well. All right, car and the passengers. Cars and the passengers. Is it something cars can exist without passengers or not? Yes. Can passengers exist without cars or not? Yes. Okay. They do not belong to each other. So we use the aggregation. All right. Okay. So cars may have passengers or may not have as well. Okay. But what about the car and the engine? Okay. Engine is actually inside the car, right? Every car must have an engine. Can the car exist without an engine? Can we run the car, drive the car? No. Okay. So that's why we use the composition to describe the relationship between the car and the engine. All right. So here we can say that cars may have many passengers. Okay. But every car must have an engine. Okay. So we use the black diamond or just the white diamond here to describe the relationship. Okay. Another one. A person, myself, can I exist without my head? No. Okay. Can I exist without my hand? No as well. Otherwise I cannot touch anything. Can I exist without my leg? Okay. No as well. Right. Okay. So that's why a person is composed of the head, the hand, the leg, the heart, everything. Okay. It cannot exist independently. Okay. Does it make sense? This is how we use the composition, okay, and the aggregation. Okay, next one. Okay, this is a has a relationship. Something has something, right? Okay, but this one is called about is a relationship, which is called inheritance or generalization, right? It's about the abstraction. Abstraction means that you want to generalize something, right? Sometimes you don't want to have like something very specific. Okay, let's say here you have multiple vehicles. Okay, in real world we have many vehicles, and the common properties of the vehicle here is that we have the speed, we have the passenger, we have the fuel type, it can go, it can stop, it can turn left, it can turn right. This is the common properties. And then we can have a separate or the child classes as well, which is called car. Another one can be called like a motorcycle. Okay, motorcycle has speed, motorcycle has a passenger, motorcycle has fuel type. They are common. Okay, Okay, does it make sense? Yeah, is-are. Yeah, so we use the is-are relationship or the generalization to create the abstraction or inheritance. Here, it means that the car inherit the common properties from the vehicle class. Okay, this is another example, right? At the university setting, there are different types of the users. It can be student, it can be tutor, it can be lecturer, it can be professor, it can be admin staff, it can be whatsoever, right? And they have common properties, which is name, ID, password, that kind of thing. The login history, the login, no, not login history, the login operation, the mark assignment, that kind of thing. Okay, so this is that's why we use the abstraction or inheritance here to describe the relationship that tutor and the lecturer classes here inherit the common properties from the user class. Okay, yep, that's right, that's what I mean. Another one, okay, this is the inheritance, okay, class inheritance, the white triangle. Motor vehicle class diagram, okay. So we have motor vehicle as a superclass, okay, and then for each of and then we have the truck, the car, and the tractor that inherits the common properties of the motor vehicle. Does it make sense? But for the car itself, we also have different types of cars as well. It could be the sport car, think about Formula One. We have the sedan car, we have the sport utility, we have the SUV, we have the van. There are different types of the car with different properties, but with different values. But the common attribute, they are the same. Doors, the numbers of doors, the fuel type, that kind of thing. The numbers of wheels, the color, they are the same. Okay, we have the same common properties. Okay, this is a very, very complex one. All right, class diagram, online shopping. Okay. So let's go to this one. We just learned about the class inheritance here, okay? So we use the white triangle arrow here, okay? So what I mean is that let's try to read this one and understand this one together. We have the cell class, okay? Cell, we have the cell date time, we have the priority code, S and H, I don't know what is that. We have the tax, we have the total amount, $10, I don't know what is that. But anyway, when we sell the products, right, we can sell at different channel. For example, it can be in store, it can be an online sale, it can be a telephone sale as well, right? So this kind of sale classes, okay, inherit the common properties of the sales class, okay, but it has its own property. For example, in store sale, they have the store ID, they have the register ID, they have the clerk ID who sell it. Online sale, you can record the time. Is it from the chat or not? Okay. Telephone, is it from who? Okay, by who? The clerk ID, and how long is the call as well? Okay. When we sell something, right? It can have for each of the sale, okay, it can have multiple sales transaction, okay, because when you sell something, you can use different payment method. For example, like mixed payment method. One can be a post, another one can be the discount coupon, another one can be the gift card. Okay, does it make sense? This is a one to many. One sale can have multiple sales transaction. Okay. Next one, okay, online card, okay, online card. So in general, online card, you can start, okay, the date time, okay, when the card is created, how many items, numbers of items in the card, how many total values, and what is the status as well, whether it is active, it is paid, or they just save it, right? That's why there are different types of the card here, okay? It can be active card, okay? This card is still active for how long? That's the elapsed time. And someone can reserve as well, reserve the purchase item, right? That they are, okay, we want to buy something, but we're gonna reserve for 3 days. This is an example, okay? This is on the reserve card. Okay. All right, next, that's why we use the inheritance to describe the relationship here. Okay, now, so for the online card here, what is next? We go to the card item. Card item, we store two data. How many items in the cart, and what is the total price here. All right, and then the cart item, let's take a look at the relationship here. The cart item, no, the cart item should be the item in the cart. All right, so that means one online card, this is a very big one. One online card can have multiple items, one or more. Zero card, we don't need really an object card here. So each card should have at least one card item. Just one item that we want to that they want to buy, one or more. And for each of the item in the card, it should be associated with the something in the inventory, right? Because that means we want to make sure that something exists, otherwise we cannot sell it, right? That means the card item should have one and only one relationship. In the inventory, we have 1,000 items. If we want to buy one, it should exist in the shopping cart. Otherwise, you should not allow the system to add that item in the cart at all if we don't have anything in the inventory, right? But for the inventory, right? Let's say I have 1,000 items in the inventory. It doesn't mean that all of them must appear in the cart item. So that's why we use a zero or more. Zero can be in the cart, or multiple items in the inventory can be in the cart as well. Does it make sense? For each item in the inventory, 1,000 items in the inventory should be associated with the sale item. So that means when you sell something, it should be associated with the one and only one direct relationship with the item in the inventory. Because if you want to sell something, it should be exist in the inventory item. But for some items that have not been sold, it may not be necessarily associated with the sale item. So we use the zero or more. Does it make sense? All right. So we have sale and the sale item here. So for here, maybe we can skip. All right. Otherwise it will take too long. Now let's take a look at the customer here. When I want to create a shopping cart, what does it mean? Each online shopping cart must have one customer. Does it make sense? But one customer can have 0 to 2 online shopping cart at the same time. That means they can have one active cart, they can have one reserved cart as well, but at most they can have only 2. It's not like multiple shopping cart, it doesn't exist, right? Let's say you go to the eBay, you go to the Amazon, you never have like multiple shopping cart. You have only one shopping cart, but in the state of the active shopping cart or the reserved one. Does it make sense? So that's why we use 0 to 2. And one customer, can also have one sale transaction here, the sale. The sale. What I mean is that each sale belong to only one customer at a time. Each sale only belong to one customer, but the customer can purchase multiple sale. They can buy many times. Does it make sense? At least one or more. All good? All right. We are nearly there. All right. Next one. So we talk about the customer already. We talk about the inventory item. The real world online shopping system, e-commerce, there must be the product review, which is not all right. Product comment, and we have the promotion, promo offer, accessory package, and the product item. So what do we mean here is that each customer, okay, can, write the product comment as well. They can write or they cannot write. That's up to them, all right? But each of the product comment must be written by at least one customer. Does it make sense? We have never seen like one comment that is written by the two customer. No, it doesn't, right? So we use one to describe the multiplicity here, okay? But one product item, okay? One product item, one product item can have 0 or more comment, okay? 0 or more comment. Sometimes the item doesn't have the comment, sometimes it has, all right? And the product comment must be belong to only one product item of its own, okay? So it cannot be like the comment is associated with multiple products. No, not like that, all right? And this is that's the relationship whatsoever. You have the accessory package, you have the promotion. We use the 0 or more, okay? Because some product item doesn't have any promotion, and some promotion they are not associated with the product item at all right? Okay. Accessory package, so accessory package is like something extra from the product item. Some product may not have accessory at all, but each of the accessory package must belong to one product item, okay? Does it make sense? All right. And I think the most important part here is the dash line, okay, in the promo offering. That's a very good question. And honestly, what is that? I also don't know, okay, to be honest. Maybe I will Google a little bit more and then I will let you know, okay, what is that promo offering. But I think in short, I would say that this is a little bit out of scope of the let's say when you do the assessment tool, you don't need to focus on the dash line, okay? So I don't know what is this one. Maybe I will need to check the book a little bit more. Yep. All right, I think that's all about the class diagram, okay? Anything else? Oh, I need to talk about the sequence diagram. Okay, I will go through it quickly. All right, a sequence diagram, basically it is a type of the interaction diagram that describe how and in what order a group of objects work together, okay, in a more sequence. That's why we call it sequence diagram. 1 second. All right, so this is the basic symbols and the component. What do we need to do in the sequence diagram? This is an example of the sequence diagram, okay? So what do we need is the actor who interact with what, right? In what order? We focus on the order of the sequence there because it's called sequence diagram, all right? Okay, we need an actor. We need the activation box. We need the object symbol, okay? So I'm gonna describe all together. This is the actor, all right? This is the activation box. This is the object, okay? Yep. And then we have the package symbol, lifeline, whatsoever. You don't need to worry about that. Lifeline is this one, okay? Lifeline. Lifeline. This is an activation lifeline. You saw that, okay? Let me get the pen. This is a lifeline. The dash line here, okay? This is the lifeline, okay? Yep. Okay. Yep. Back. And then we have alternative symbol. We have the synchronous message, okay, with the solid line and the solid arrowhead. So we use the asynchronous message symbol, a solid line with a line arrowhead, reply message, which is the dash line with a line arrowhead, okay? So I think mainly what do you need to understand and remember is the synchronous message symbol and the reply. Whenever This symbol is used when a sender must wait for a response, so we need a response, okay, to a message. Before it continues, the diagram should show both the call and the reply. That's why, yep, whenever we have this, we're gonna have this, the reply. And this is represented by a dash line with a line arrowhead, replies to the call, okay. First, who is calling, yep, with the synchronous message symbol, and what is the reply, all right. Okay, now let's explain this one together. This is the use case sequence diagram for the customer account creation. Okay, to create a customer account use case, then what is a sequence diagram? How each of the object interact with each other, that kind of thing. All right, let's go through it. Draw. All right, so first we start from the actor, the clerk, okay, the clerk. We have the customer handler, okay, so let's say we implement using OOP, we use the, what is that, model view controller pattern, that kind of thing, you know. We have this one that manage the activities, the operation whatsoever, and then we have the customer class that actually just collect the data, all right. This is this one, the operation, the method in the class, which is called create new customer, okay. And to create new customer, right, we need to collect this kind of data attribute, the name, mobile phone, home phone, and the email address. So the clerk send a message to this object, a customer handler, and the customer handler also send a message to the customer, right? Okay, that okay, we're gonna create create a new class, a new object, okay, a new customer here, okay, from the customer. So once the customer class here can create a new customer successfully, right, then it can reply a message to the clerk that, hey, look, yeah, we can create successfully, all right. Next, the clerk can enter the address, so they need to enter the type, the street number, the city, state, zip code, that kind of thing, okay. So they put the data here, the customer handler will forward the data to the customer, okay, and then it can create the address, okay. Once the address class can be created successfully, then it will return the data, return a reply message, right, back to the customer handler that, hey, look, yeah, the address can be created successfully, and return to the clerk as well, okay. Enter account, same one, okay. Enter account, let's say if the clerk want to create they want to enter the account number, and this is the account, could be bank account, you know, checking or saving, what is a code number whatsoever, right. So they forward the data, okay, from the customer handler to the customer class, and forward to the account class here, okay. And then if it is created successfully, then the customer will return everything back, return message here that, hey, look, the account can be created successfully, okay. So this is the sequence diagram that actually describe how each of the objects or the classes interact with each other. Okay, I think that's all for the today lecture. And yep, if you don't mind, I hope everyone enjoyed the lecture today. The lecture today is quite important for the assessment too. And then next week, we're gonna talk about the introduction to software quality and testing, which you will need to work for the use that kind of knowledge for the assessment 3 and 4. All right. Yeah, from next week onwards, the activity in the apply session maybe involve some implementation, unit testing, that kind of thing. Should be week 7, 8 and 9, there will be unit testing activities. If you if you are not good at programming, I recommend that you should start practicing it as soon as possible. All right. Okay. I think that's all for the lecture today, and I hope you enjoy. Yeah. So good luck, everyone. All the best. I hope you enjoy the rest of the week, and then yeah, we will see you again next week. Thank you so much.